PremierU family. I've got a hot one for you today. I want to talk about GHK-Copper. GHK-Copper is one of those very interesting compounds that actually has a lot of human research, which is a very important factor. In a world with so much preclinical data and animal model research, we actually have something here with a ton of human data. This is a structure that's been studied, or excuse me, a compound that's been studied since the early 1970s. Most of the human data does exist with topical application, but there are broad systems-based applications that can be inferred from this with preclinical data, in addition to a very nice safety profile. GHK-Copper becomes a very important structure for repair and recovery, and here's why. Think of it like a systems level regulator. So we talk often about how important environment is in our ability to recover, repair, and have just ultimately good cellular function. That environment is so important because you can put a very good tool in a poor environment and it can either not work or it can amplify dysfunction. So let's talk about GHK-Copper itself. So GHK, that first part is glycyl, histidyl, and lysine, bound to a copper. Now, ultimately, copper is a very potent mechanism. If attaching to the incorrect tissues at the inappropriate time, it is a major redox disruptor. However, this glycyl, histidyl, and lysine creates a square planar geometry around copper, protecting our tissues until just the right time. When it goes in, this is the cool part. It's a gene modulator. It has been proven to affect and modulate 4,000 plus genes in the human. Now, that might sound scary at first, but the reality is what we found is the majority of these are just favorable. They've not found any deleterious movements as a result of these gene expressions. That distribution breaks down into some upregulation and some downregulation. Approximately 30% of the gene transcription expressions are upregulation of appropriate factors promoting healing and recovery and repair. The remaining are downregulating. So let's talk about some of those factors, some direct actions of GHK-Copper. One is very important from an inflammation reduction agent is direct suppression of NF-kappa B. NF-kappa B is known to be a major contributor to pro-inflammatory states. NF-kappa B goes into the nuclear center, creates cytokine release. So things like IL-1 beta, tumor necrosis factor alpha, IL-6. These other factors that are known to be pro-inflammatory and create inflammation throughout the body. Now, they're not always bad, but if in an appropriate state, they can be negative as a result of excessive expression. So GHK-Copper goes in to suppress that NF-kappa B expression of cytokine release. In addition to that, so the other side, the protective mechanisms, it activates something called NRF2, which is the master regulator for the antioxidant response elements. So these are things like superoxide dismutase, catalase, and then one of my favorites, glutathione peroxidase. So these are the things that are going out and helping to protect you from things like reactive oxygen species, free radicals, these bad agents that can float in excess throughout the body. They're not always bad, but if they're left unfettered, if they're left to go unregulated, they can be very problematic. In addition to that, we know that there are direct repair mechanisms that GHK-Copper affects that are very unique. Things like nerve growth factor, neurotrophin 3, neurotrophin 4. These have been studied in peripheral neuropathy models as well as in other nerve injury states. And it's a phenomenal agent as a result of that. In addition to that, and this is something that is seen very commonly in skin or just in other tissues, is its ability to modulate transforming growth factor beta. Now, transforming growth factor beta is very important in the recovery process, but it can get skewed. As a result of stabilization of something called metal metalloproteinases, we get improved deposition of certain types of collagen. So not only just type 1 collagen, which tends to be more fibrotic, we get appropriate distributions of collagen 1, collagen 3, and there's other stabilization mechanisms, which leads ultimately to more compliant tissues, more bounded tissues, tissues that are healthier, that have a better extracellular matrix. So we've set the environment for better healing and better recovery of tissues that are more durable and more resilient ultimately. One of the last things I do want to talk about, because we get it often, is to talk about its utility in hair loss. Research is mixed with this, meaning that the outcomes are mixed. I think if you pick the appropriate person, GHK-Copper can be an effective hair loss agent. If you look at how it works, it helps to stabilize something called hepatocyte growth factor in the follicular cells. So in a person who has alopecia, who has TGF-beta 1 mediated follicle miniaturization, you're going to get stabilization of that. In addition to, it extends the anagen or the growth phase factor of the hair follicle. So you can get more durable hair follicles. You can get some recovery of the hair follicles as well. I wouldn't say that it's robust, but it does have an application there that people do get some regular benefit over time. Remember, most of these things, this is a marathon and not a sprint. This is something that has to be used appropriately, and the system has to be good. In addition to that, there is that anti-inflammatory benefit to the scalp, and reducing inflammation at the scalp, promoting blood flow, can be a very favorable thing for those hair follicles. So hopefully, after this brief overview of how this agent actually works in the body, you can see why it's so sought after and why it's ultimately so effective if put into the right system. And ultimately, when it's used to create favorable changes in a system, you're going to see that other agents that are used, other peptides, other supplements, other lifestyle factors are going to be enhanced because you've changed that environment. So I hope that this is helpful. You definitely want to use these agents appropriately. This is preclinical data, and this is not something that has been done in large patient cohorts. So we have to be very appropriate when we're choosing these agents, but they can be very impactful. All right, take care.